Everybody, welcome back to chemistry. And so now I want to do achieve number 6, question number 7. So if I can blow that up really quickly. It says an office heater puts out 2050 BTUs, which stands for British Thermal Unit, of energy in the form of heat per hour. Given that 1 BTU is equal to 1.055 kilojoules, how many megajoules of energy in the form of heat can be produced per year by the heater, assuming continuous operation? Okay, so if I can minimize the slide, please. Okay, so this isn't too bad of a problem. So what I might want to do is start out by figuring out, in the end, what are we trying to find? So what we're trying to find is the amount of heat in megajoules per year that this heater is putting out. So in the end, what we want is an answer in megajoules. So mega is capital M, joules is J, per year. So one of the things you'll learn later on is that joules is a unit for energy, and so just sort of accept that for now. We'll talk more about what that means when we get to chapter 6. Okay, so let's go ahead and write down some of the information that we have. It says the office heater puts out 2050 BTUs of heat per hour, so I can write 2050 BTU per hour. So we're going to have that. BTU is also a unit of energy. Now, we're actually given a conversion there of BTUs to something closer to joules. We're given a conversion from BTUs to kilojoules. So it's 1 BTU over 1.055 kilojoules. This is how I suggest you solve the problem. I suggest you start out with 2050 BTUs per hour, and then what you want to do is use this conversion to get this into kilojoules per hour. Okay, and then the rest of the problem isn't so bad. What you'll have to do is convert kilojoules to megajoules per hour, and you might need a couple of conversions to do that. And then you're going to finally have to convert megajoules per hour to megajoules per year through using a number of conversions. Okay, so let me just go ahead and set up this train of fractions to solve the problem. So again, I suggest you start out with 2050 BTUs per 1 hour. And then the next thing we want to do is get BTUs per hour into a new unit of energy, which is kilojoules per hour. And so we are given a conversion between BTUs and kilojoules, and so I'm going to go ahead and just plop that in here. So we have 1 BTU and 1.055 kilojoules in the numerator. Okay, so the next thing I want to do is maybe cancel out units just to see where I'm at. So BTUs cancels out. And so now I can see I have kilojoules per hour. So now let's get kilojoules per hour into megajoules per hour. So let me just quickly write out fractions here. So we need 1 kilojoule here and 1,000 joules here. Okay, and then I have to convert joules to megajoules. So I'm going to need 1 megajoule in the numerator. And then you might recall that a megajoule is 1 times 10 to the 6 joules. So it's 1 times 10 to the 6 joules in the denominator. And so let's just see where we're at now. And so what you can see is kilojoules cancels out, joules cancels out, and now we're at megajoules per hour. Okay, so finally you have to get this into megajoules per year. So that isn't so bad. So what you want here is how many hours are in a day? As I recall, there are 24 hours in a day. So we're going to have 24 hours in 1 day here. And then finally we convert days to years. And so what we want to do is we want to have 365 days here in the numerator, and then 1 year in the denominator. Okay, so now I think you can see is that the hours will cancel out, the days will cancel out. What you're left with is megajoules per year. So you should have in the end some kind of number here in megajoules, excuse me, that should be a capital M, my mistake, per year. Okay, so when I did this earlier and I did the math, I got 1.894569 times 10 to the 4 megajoules per year. And so you will have to round this to 3 significant figures. And so if you do that, I get 1.89 times 10 to the 4 megajoules per year. And that should be the answer. Okay, thank you for listening to that. We will see you next time.